1. Okay, Loren.
Hi.
What have we done?
We've automated the double slit machine here. This is a stepping motor, and it drives a little tooth belt, and replaced the knob on the voltage control with a sprocketed belt. And it's a sprocket, belt sprocket. And what we have here is an Arduino, our Uno, the simple old one, and a motor shield to drive the stepper motor. And this board over here is the power control. It's got a latching relay on it. And so what we do is we take the 15-volt power from the nominal unit here and control it via this relay. And so we can turn on the lamp over there, and it turns on the rest of the equipment. So the way the works in operation is when you power it up, the motor is told to rewind until it stops, because we want to make sure that the voltage is at 0 when we apply the light. Mm-hmm. So it does that by rewinding the motor, and this little red thing here has an infrared sensor on it that's reading the teeth on the gear, the sprocket here.
Which are painted black and white, right?
They're painted black and white, and so there's an infrared sensor. So when it sees the same color for more than 5 steps of the stepping motor, it knows that it's stalled, and then it's rewound all the way. Mm-hmm. So then, this is just a power up. So then when you want to make a run, what you do is you send it a character 1 through the serial line here, like typical serial port, USB. And the computer then turns on the lamp over there, and it steps the motor about 1,460 times to get it to where it would say 7.8 if we had a knob on there. And that sets the sensitivity or the voltage of the photomultiplier. And then we can see counts over here on the counter box, and we know it's working. And then when you're done, you want to turn it off. You send it to 0, and it runs the motor backwards all the way to 0, and then it shuts off the light. And then at the end of each of these operations, it echoes the character that you sent. So in the case of turning it on, it sends you a 1 back to tell you that it turned on. In the case of turning it off, it sends a 0 back, so you know that it's
every time when it's done with its process.
So then you can proceed to do other timing and analysis and whatever you need to do.
Yeah, it's beautiful.
It's pretty solid. I'm quite confident that it will last without any maintenance at all.
Yep, and that's all needed because we have to slowly ramp up the voltage.
Mm-hmm.
So we don't destroy the photomultiplier.
And there's no digital way to do that.
Yeah.
Because I'm not going to take it apart. There's this really nice knob here that controls the voltage. And all I had to do was just come up with a way to do it by machine instead of fingers.
Right. And so when I say what we did, what I mean is what Loren did, and I watched, and it was very exciting.
Yeah. It took about 3 days to put this together, program it and put it together.
Very cool.
Okay.
All right, so shall we see it in action?
Yeah, let's see it work.
Okay.
So here's the Arduino console window, and I'm going to send it a 1. Okay. There it is. Winding 7.8 turns to the correct pressure.
Right. And so the gate to the photomultiplier is in the open position, so we have to do this gradually so we don't burn out the photomultiplier.
And then we can start seeing counts come in.
Awesome.
Okay, now turn it off.
Now it's a 0. Now what we should see here, so it's going to ramp it down.
See, the echoed character setting a 1.
So we should see a 0 when it's
It
done.
will pop up as soon as it stops turning.
All right, I'll keep my camera here. You can hear it. So when the motor sort of says, just before it starts smoking.
There.
0. Boom.
Popped up.
Thanks.
Okay.
You're amazing.
See, it works.